Welcome back. We are in activity 1.2 of Rollin', talking about probability. In this activity, we're talking about complementary events. Now, in the last activity, we got a taste of it, but in this activity, we're going to go in depth of what a complementary event is. So let's read. It says, in the previous activity, you calculated the probability of complementary events. Complementary events, please highlight that or underline whatever you have, are events that together contain all of the outcomes in the sample space. One way to notate the complement of an event, A, is not A. For instance, suppose that P, or the probability of even numbers, represent the probability of rolling an even number on a number cube. Then P, not even, or the probability of not even, represents the probability of rolling a number that is not even on the number cube. I guess I didn't have to explain that when reading. Oh well, anyways. So number 1 says, consider the events from activity 1.1, questions 5 and 6, rolling an even number and rolling a number that is not even. What do you notice about, and this is the main question here, what do you notice about the sum of the probabilities of these two complementary events? So I'm going to scroll back up to questions number 5 and 6 so that you can see. Oh, I didn't mean to do that. Number 5 and 6 are here. So the probability of rolling an even number we saw was, and I'll even highlight it, was 1/2. And then the probability of rolling a not even number was also 1/2. What do you notice about, oops, what do you notice about the sum of those two numbers? Meaning, when you add those, what do you get? What do you notice? And then I actually want you to answer the second question too while we're here. Number 2 says, consider the events from activity 1.1, question 7 and 8. So I'm just going to paraphrase or skip ahead. What do you notice about the sum of those probabilities? Let me go back up and show you. So the probability of rolling a number, hold on, scroll up some. Oh no, there we go. The probability of rolling a number greater than 4 was 1/3. And then the probability of rolling a number that is not greater than 4 is 2/3. What do you notice about those two probabilities? The sum specifically. What do you notice about the sum of those two probabilities? Take about 1 minute and answer questions 1 and 2 in activity 1.2. Take 1 minute. Pause here. Alrighty, let's compare answers. So number 1, you should have noticed that 1/2 plus 1/2 gives you 1 whole, or just 1. And then 1/3 plus 2/3 is also equal to 1. So now let's answer question 3. It says, what is the sum of the probabilities of any two complementary events? Explain why your answer makes sense. So we'll talk about this. So with those complementary events, and I want you to take notes here and answer that question number 3. With those complementary events, you'll notice that the sum of two complementary events will always equal 1 whole, or will always equal 1. So make sure you write that. Alrighty, so I typed it so that you've got something to refer to, but I'm going to go ahead and move on. You can shorthand it if you need to. Number 4 says, the probability of rolling a 5 or less on a number cube, or the probability, parentheses, 5 or less, parentheses, is equal to 5 out of 6. Leah and Jasmine calculate P, or the probability of not 5 or less. Their work is shown. So Leah's work is shown and Jasmine's work is shown. What I want you to do, explain the difference between Leah's strategy and Jasmine's strategy. At this time, set your timer for 2 minutes, and that is it, 2 minutes. Then we're going to compare answers. Pause here. Alrighty, let's compare answers. So notice that Leah, in her work, she calculated the complementary event knowing the total added to one whole. So if she already knew that the probability of five or less was 5 out of 6, she just knew that the complement was going to be 1 out of 6 because that was going to then add up to 1. And then Jasmine, looking at her work, she subtracted the probability, the known probability, which was five or less, from 1 to determine what the complement was. So they essentially have the same idea. They both knew and understand that the complementary events, meaning the probability of rolling a 5 or less, and also not rolling a 5 or less, added to be one whole. Alrighty, that concludes the learning for this activity. I will see you in the next video.